Section 1.4, Composition of Functions. In this section, we're going to perform algebraic operations on functions and evaluate a composition of two or more functions algebraically from a table and from a graph. We can combine functions using arithmetic. So when we say arithmetic, what we're talking about are the basic operations of adding, subtracting, multiplying, and dividing. We can do this in general and for specific input values. For example, f of x is equal to 2x plus 1, and g of x is equal to x squared minus 3x. For specific values, let's find f plus g of 3. So first we're going to find f of 3. So to find f of 3, we evaluate the function f at 3. So 2 times 3 plus 1. So f of 3 turns out to be 6 plus 1, or in other words, 7. Next, we'll find g of 3. So g of 3 would be, again, we just plug in 3 for x, 3 squared minus 3 times 3. In other words, 9 minus 9, or 0. So f plus g of 3, we found f of 3, which is 7, and we're going to add g of 3, which is 0, and this gives us an answer of 7. Find f times g of 5. So what this means is we're going to find f of 5, and then we're going to find g of 5, and then we're going to multiply our two answers together. All right, so f of 5 is 2 times 5 plus 1, or in other words, 11. G of 5 is 5 squared minus 3 times 5. This is 25 minus 15, giving us a result of 10. And so f times g of 5 means to take f of 5 and g of 5 and multiply them together. So if we take 11 times 10, we get a final answer of 110. Finally, f divided by g of negative 2. What this means is we're going to find f of negative 2, and then we're going to find g of negative 2, and then we're going to divide our answers. So f of negative 2 is equal to 2 times negative 2 plus 1, or in other words, negative 3. G of negative 2 is negative 2 squared minus 3 times negative 2. So negative 2 squared, negative 2 times negative 2 is positive 4. Negative 3 minus 2 is a positive 6, and so this gives us a value of 10. And so we're going to take f divided by g. So f divided by g is negative 3 over 10. And we can just leave our answer like this. We don't have to divide that out or write it as a decimal. So those were examples of specific input values. So specific input values means that your input is a number. We can also do this in general. So in general means that your input is an expression, something involving a variable. So for example, if we did the same thing, only we asked ourselves, what is f plus g of a? That means we're going to plug in a into f, we're going to plug a into g, and then we're going to add our answers together. So let's take a look at what that would be. So f of a is simply 2 times a plus 1. G of a is a squared minus 3a. And so f plus g of a, we would take our first answer, 2a plus 1, and add our second answer, which is a squared minus 3a. And if we simplify that, that would be a squared minus a plus 1. So when you input an expression, your output is also an expression. We'll do one more. What if we wanted to do f times g of a? So again, f of a is 2a plus 1, and g of a is a squared minus 3a. And what we want to do is we want to multiply those two answers together. So we would have 2a plus 1 multiplied by a squared minus 3a, and then we're going to simplify. So we're going to simplify by distributing 2a cubed minus 6a squared plus 1a squared minus 3a. And if we simplify this, that would give us 2a cubed minus 5a squared minus 3a. So those would be examples of general terms where you input a variable and your answer is a variable. In the first examples, we input a number and our answer was a number. So that's how you would do arithmetic with functions. And in our next video, we're going to take a look at function composition.